Okay guys, so now we're going to be looking at 3 by 3 equations. So that means we're going to have 3 different linear equations. And we're going to be doing 3 by 3 substitution. So first we're going to go through the steps, and just like we've done on the other ones, we're going to have 2 different versions of it so y'all can understand 2 different ways. So we're going to look at all 3 equations. You're going to look for equations that have a coefficient of 1. This is going to make your life a lot easier. You're going to solve one equation for a missing variable. Then you're going to substitute from step 1 into the other 2 equations. You may only have to substitute into one equation. It just kind of depends. Then you're going to set up a 2 by 2 system and solve by elimination if needed. And then last, you're going to substitute in the values from step 3 to find the third variable. So that seems like a whole lot of words, and I totally understand that, and it kind of seems very vague. That kind of is the thing with substitution, especially with 3 by 3 equations, okay? So I'm going to go through our other steps here and see if it's going to help a little bit more, just like it has on our other ones. So 3 by 3 systems of linear equations have 3 variables and 3 equations. So we've already dealt with 3 variables with our x, y, and z, for instance. This time we just have 3 versions of that, x, y, z, x, y, and z. So now what we have to do is the solution to a 3 variable system of equations is going to be ordered by, instead of an ordered pair, it's going to be an ordered triple. So that's going to look like parentheses x, comma, y, comma, z. So here are our steps to solve 3 by 3 systems of linear equations by substitution. So we have our original equations. We have a plus b plus c equals 6. It's our first equation. That's why we have a little 1 over here. Then we have 2a minus b plus 3c equals negative 59. That's our little 2. Then we have a minus b minus c equals negative 12, and that's our little 3 over here. So guys, the first thing I'm going to do is I'm going to make one of these equations isolating the variable. So that's our first step right here. Isolate the variable. So the one I find that might be the easiest is going to be our first equation. So that's going to be my a plus b plus c equals 6. And I'm going to make this entire thing equal to a. So that means my equation is going to become a equals 6 minus b minus c. Because if I minus my b on this side and minus my c, I get it on this side. Okay, so now that I've isolated one variable, now I have 2 of my 2 other equations next. So what's going to happen now is I'm going to substitute that expression representing that variable into both of the other equations so that I now have a 2 by 2 system. So that means I'm going to have 2 times, and my a is going to be in blue, and it's going to be 6 minus b minus c. And then I'm going to have negative b plus 3c equals 59. So that right there, guys, is my first one. Then I'm going to plug in with my second equation right here. Okay, that third equation, I guess. And that's going to be my next part. So I'm going to have both of them separated out. So I'm going to put this one down here, and that's going to be parentheses. I'm going to plug in 6 minus b minus c minus b minus c equals negative 12. So guys, the reason I separated those is I want to simplify them down before I have them as my 2 new 2 by 2 equations. So my first one, I'm going to distribute my 2 in all the way. That's going to give me 12 negative 2b minus 2c minus b plus 3c equals negative 59. And now I'm going to combine like terms. So I'm going to end up with 12 minus 3b, because I've got a b and a b, plus c 3c and negative 2c equals negative 59. So now that is my new equation right there. It can be still simplified one more because I've got my 12. So I should end up, my final one should be negative 3b plus c equals negative 71. That's the simplest it can go. So that's one of my new equations is right here. My second one, now we're going to do the same thing. And all we have to do on this one, guys, is combine like terms because it's going to be 6 minus b minus c minus b minus c equals negative 12. So I'm going to have 6 minus 2b minus 2c equals negative 12. Then I'm going to end up with negative 2b minus 2c equals negative 18 because I'm going to move my 6 over. And then I can actually simplify this out even further. If I divide every piece by 2, I end up with negative 2 actually. I'm going to end up with b plus c equals 9. And that's going to be my second part of the equation. Okay, so now I have 2 new full equations to go through. So that was our substituting in to create 2 new equations. So our 2 new equations end up being negative 3b plus c equals negative 71. And then b plus c equals 9. So here's our 2 new equations. Now we're going to solve the 2 new equations for both of its variables. So what that means, guys, is I'm going to make this simplified out, and I'm going to choose one of them like we've done in the past to actually solve for the equation. So we're still doing substitution. So what that means is I'm going to take this first one right here because it's my simplest, and I'm going to solve it for c. So I'm going to have c equals, we're going to make it equal to c. So we've got b plus c equals 9. If I minus my b on both sides, I end up with c equals 9 minus b. So then this, I can plug in the c into the other equation. So I get negative 3b plus 9 minus b equals negative 71. So I'm going to end up with 4b plus 9 equals negative 71. And then I'm going to have negative 4b equals negative 80 because we're going to move that 9 over. And I end up with b equals 20. So then this, I'm going to plug back in over here. And that's going to give me c equals 9 minus 20, which means c equals negative 11. So I have 2 of my variables now. And now I have to plug both of those in to get my a. So we're going to go back to the easiest one that we had before, which was a plus b plus c equals 6. So I'm looking for a. That's our mystery one. But then we have plus b, which is 20, right here. And then we have plus negative 11 is going to equal 6. So 20 minus 11, because that's basically what that is right there, is going to be 9. So that means we end up with a plus 9 equals 6. When we subtract our 9 from both sides, we get a equals negative 3. And that's our term. So now we're going to do an ordered triple. So that's going to be A, B, and C. So that means my final answer is going to be negative 3, 20, negative 11. So don't get scared about all of this stuff, because understand that substitution is a puzzle, and you may or may not be able to follow these steps every single time. There are many ways to solve it. So y'all could have done a totally different version of this. This is just to give you an idea of what it is. So there are some special solutions, and basically that just means that they can have solutions, that 3x3s have solutions at exactly 1 point. And so what that means is that's like the x, y, z. This occurs when the 3 planes by the three equations intersect at one location. So that's this part, so right here. If the system has no solutions, one of the variables will eliminate, resulting in false statement. So that means something about it is not true, such as 0 equals 1. This occurs when there's no location at all three planes, which we've talked about before with the two of them. If the system has infinitely many solutions, one of the variables will eliminate, resulting in a true statement. So it's exactly as we said before, guys. So if there's something that's always true, it's going to be infinitely many solutions. If it's not, then we're going to have no solutions. Again, when we identify solutions to a system by substituting the values potentially in each thing, in order for an ordered triple to be a solution, it must be true for all of the equations in the system. So make sure you understand that it has to be good for all of them, or it cannot be the ordered pair. So that's why checking your solutions is so important, because if you don't check them, you can't get through them. Okay, so we're going to do a little bit of practice on some of our substitution. So my first one here, guys, we have 3 different ones. Super easy. The first thing that we notice, though, is we can actually solve right here what z is. So we're going to do 3 divided by 3, and that's going to get me z equals 4. So just right there, you can plug in 4 for both equations. And that's your first step. So that's going to get me 3y minus 4, which is our z, equals negative 1, which will be ended up being 3y equals 3. Then 3 divided by 3 equals y equals 1, which we then can plug in back to the the other equation that we haven't done yet. So that means our last one is going to be x plus 2 times 1, which is our y, plus 4, which comes from our z, equals 9. So that means I end up with x, so 2 plus 4 equals 6, equals 9, and then minus 6 on both, and I get x equals 3. So that means my ordered pair, ordered triple, is going to be 3, 1, 4. And that's our answer right there. So now we're going to do the same thing, and we're going to move on to B. So on B, you can try to do this any way you choose. But I'm going to take this bottom one right here, and I'm going to find it equal to A. So that means I'm going to subtract my 2c to both sides and get A equals negative 2c plus 10. So now this A can be plugged in right here because it's the only one that has an A. So that's going to make a difference, guys, in which one you can use because it doesn't have an A. So then you're going to plug that in, and I'm going to have negative 2c plus 10 plus b equals 3. And then I'm actually going to bring down this next equation after I simplify it. So it's going to be negative 2c plus b equals negative 7. We're going to bring down this equation right here. But we're going to switch up that order just a little bit on our first one. So that's going to make it b minus 2c equals negative 7. And then we're going to have negative b plus c equals 3. Notice how, guys, all I did here was rotate my 2c and my b. I didn't change anything else. The reason I did that is strictly so this numbers could be opposite and we could do elimination. So I'm doing elimination right here. In doing that, so that means my b's cancel, and I end up getting negative c equals negative 4, divide by negative 1, and I get c equals 4. Now, I can now plug back into my other equation, so I can do negative b plus 4, which comes from my c, equals 3, and then I get negative b equals negative 1. When you divide by negatives, I'm going to get b equals 1. And then my last thing I have to do is I have to plug in that 1. for my a equation. So I'm going to take my a plus b, which is going to be 1, because you're going to pull that 1 from right here, equals 3, minus my 1 on both sides, and I get a equals 2. So then my ordered triple would be 2, 1, 4. Okay, so these ones have been relatively easy. You haven't had to do a ton of work to get through them. So now we're going to move on to a little bit more difficult ones that take just a little bit more work. Okay, guys, so now we're going to finish that C, D, and our final one for this substitution 3x3. So guys, on this one, we're going to actually number our 3 equations so we know which ones we're looking at. So we have 1, I have 2, and then 3. So what's going to happen is we're going to be looking at these each different ones. So first thing that I'm going to do is I'm going to look at the one that I want to solve for x. And I think I'm going to go with 2 because I've got the coefficient that has 1. So I'm going to use my 2 down here so I know it's separated. And I'm going to come up with x plus 5y equals 9. So I'm going to minus the 5y on both sides. And I'm going to end up with x equals negative 5y plus 9. So I like it like this just because it can be a little reordered so I can work on it for something else. So now what's going to happen is I'm actually going to plug this in for the third equation and the first one. So my third equation is 4z minus 5x, so my x is going to be implemented right here. It's going to be negative 5y plus 9 equals 9. I'm going to solve this one real quick, and I'm going to reorder it just so it makes a little bit more sense to me in just a minute. So I'm going to end up with 25y and then plus 4z and because that's a 9 right here, it's going to be minus 45 equals 4, because this is a 4 right here. So that's going to be what that one is right now. And that's about as simplified as we can go besides moving our, we're going to do our 45 too, plus 45. So I'm going to end up with 25y plus 4z equals 49. So now we're going to look at that first equation. So that first equation is going to be my 2 times, and we're going to have our x implanted in, so our 5y plus 9. And then it's going to be plus 3y minus 2z equals negative 1. Okay, so we're going to do the same thing. Distribute that 2 in. I'm going to have negative 10y plus 18 plus 3y minus 2z equals negative 1. Simplify that down, I will end up with negative 7y minus 2z equals negative 19. So I have my 2 equations now, right here and right here. What I'm going to do is I've got to make these be opposites. So if you notice, I've got a 2 and a 4. So if I wanted this 2 to be opposite, I'm actually going to multiply it by 2. So I'm going to end up with negative 14y minus 4z equals negative 38. Now I'm going to bring down this equation down here and have 25y plus 4z equals 49. So as y'all can see, guys, we have a cancellation right here, and that's perfect because now we're going to add. So that means I'm going to end up with 11y equals 11, which means my y is going to be 1. So I have that now. So now I can plug in my y to figure out my next part of the equation. So if I plugged in y for my x equation up here, so I'm going to bring it back up to the top, guys, so y'all can see it. So I have x equals negative 5y plus 9. So I'm going to do times 1 plus 9. So I end up with negative 5 plus 9. So my x is going to be 4. And now that I have both of those, I can plug it into the next equation. So I have 4z minus 5, and it's my 5x, so that's going to be my 4 equals 4, which is going to give me 4z equals 24, which leaves me with z equals 6. So that means my ordered triple is going to be 4, 1, 6. So as you can see, guys, that takes a little bit more work, but it does get you through it very easily. So now we've got one more example before we do a word problem. So again, we're going to number our systems just so we make sure that we're doing the right thing. So I'm going to look for the one that has the leading coefficient, and that's going to be my 1 equation. So that's the one I'm going to solve for x. So I end up having x minus 4y plus z equals 6. So I'm going to add my 4y and minus my z, which is going to get me x equals 4y minus z plus 6. Okay, and so now I've got to plug in my x for both my second and third equation. So for my second equation, it's going to be 2 times 4y minus z plus 6 plus 5y minus z equals 7. So simplifying that down, we're going to distribute all three, and I'm going to get 8y minus 2z plus 12 plus 5y minus z equals 7. And again, I got to simplify that down even more. So I've got 8 and I've got 5. That's going to give me 13y. I've got a negative 2z and a negative z, so that's going to give me negative 3z. And I move my 12 over to my 7, and I'm going to get negative 5. So this is our second equation now. So I'm going to do the same thing with our third equation. So I've got my third. It's going to be 2 times x. I'm going to plug in that 4y minus z plus 6 again. Then it's going to be minus y minus z equals 1. So I'm going to distribute that 2 in. So I should get 8y minus 2z plus 12. So look how similar that looks. Minus y minus z equals 1. Simplify that down again. I'm going to have 8y minus 1y, which is going to give me 7y. I'm going to end up with 3z again. And then I'm going to move my 12 to my 1, and I'm going to have negative 11. So I now have my 2 equations right here. So what that's going to mean is now I can start solving using those 2. As you can see right now, I have a 3z, negative 3z, and a negative 3z. I need one of those to become positive. So I'm going to make my 13 the one that goes positive. So I'm going to do this entire thing times negative 1. So that's going to end up giving me negative 13y plus 3z equals positive 5. And I'm going to do elimination. So mine will cancel here. And I'm going to end up with negative 6y equals negative 6, which means my y is going to be 1. So now I can plug in my y for mine of my equations. So the equation I'm going to look at is the one right above that I just did. So it's going to be my 7 times 1 minus 3z equals negative 11. So that's going to end me with negative 3z equals negative 18, which means my z is going to be 6. So all I have to do now is plug in my last part of this equation. So we knew that x equals 4 times, from our equation, 4y minus z plus 6. So we know both of these. So 4y, so 4 times 1, minus 6 plus 6. So that means these are going to cancel, and I'm going to end up with x equals 4. So that means my ordered triple is going to be the exact same as our last one. 4, 1, 6. So they have the exact same intersection point of our different planes. So now, guys, we've got our last one, which is going to be our word problem. So with our word problem, guys, first we have to set it up a little bit. You have to write our equations just like we did on our 2x2. So we have Alex Bart, and Carl are brothers. Alex is the oldest. Carl is the youngest. The sum of the ages is 42. Alex is 3 more than twice Carl's age. And the difference between Bart's and Carl's age is 7 years. Find the age of each brother. Okay? So, first thing, one and easy, done, is we know that our first equation is Alex plus Bart plus Carl is going to be 42. That's our easiest one because it's the sum of all the ages. Next, we're going to look at our next sentence, which is Alex's age is 3 more than twice Carl's age. So that's going to be our second one. So we know Alex has to equal 3 more, so plus 3, of twice Carl's age. So now we just came up with our second equation. Now we have one more. The difference between Bart and Carl's age is 7. So our third equation is going to be Bart minus Carl is going to be 7. So right here, guys, we already have our equations. And we made it really easy on ourselves because one of them already has an isolated variable. So what's going to happen is we have our simple one. We're going to plug in what A is for one of our equations. We're going to plug it in for our first one. So we have our first equation. And I'm going to have, instead of A, I'm going to put the 2C plus 3. And then plus B plus C equals 42. Okay, once I simplify that out, we see I've got 2C, so that's actually going to give me 3C plus B. And then my 3 is going to go to the far side, which will give me 39. If I reorder this a little bit to make it equal to my third equation, I'm going to switch it and just make it B plus 3C equals 39, because all that did was switch these back and forth. So now I have B minus C equals 7. So we're pretty close, but what I want to do is I want my b's to cancel. So I'm going to make this entire thing multiplied by -1. So that means I'm going to have negative b, positive c, negative 7. And now I'm going to add. So my b's will cancel, and I'll end up with 4c equals 32, which means if I divide by 4, that means Carl's age is 8. So now I can plug in and find my next ages. So we know our third equation was b minus c equals 7. Well, if we know what c is, which is 8, so it's going to be b minus 8 equals 7. I add 8 to both sides, and I get b, Bart, is 15. So now I just have my last part, which is a. Well, remember, we already had an a equation. That was our second one. So it's a equals 2 times Carl plus 3. So 2 times Carl, which is 8, plus 3. So that means we're going to have 16 plus 3, which means that Alex's age is 19. So when we write out our stuff, it's going to be Alex is 19 years old. Bart is 15 years old. And Carl is going to be 8 years old. Remember, you guys can always check this by plugging these numbers back into our original equation, which would be 19 plus 15 plus 8, which is going to be your 42. So then that means you check out there. And you can plug them back into each different equation to make sure they all match up. But that's going to be the end of our 3x3 substitution notes. If you have any questions, remember, please come to AP and ask anything you need.